Hi there, this is Math 2, Unit 5, Worksheet 7, using coordinate geometry to prove properties of quadrilaterals. And so today we have some quadrilaterals that are here on the coordinate grid, and we have to then determine what their points are going to be. So first of all, we have a rectangle with a base B and a height H. So that means the base has a length of B out to here. So we'd say that has a length of B out to there, okay? Technically, we probably would call that negative b based upon where it is on the coordinate plane. And the height over here is at h. That's how high up it's going. So this point is negative b and that point is h. So in terms of our coordinates, this point A is over at negative b and we're up a value of h there. So negative b comma h. The point B on the x value is still on the y-axis, so that's 0, and we're up a height of h. For C, we're at the origin, 0, 0. And for D, we're over here at negative b, and we're at a height of 0 there. So that's kind of what I would say for the coordinates for number 1. Looking at number 2, similar idea. There's a rectangle centered at the origin with base 2b and height 2h. If it's 2b, that means out to here, this is going to be a length of b out here, which would make this a length of negative b. Imagine if it was just 2, we would say that the length is 2, we'd say that's 1 and that's negative 1, okay, which makes this also a b and a negative b. And in terms of the height, it says it's 2 height, so the height here is h and the height here is negative h, the height here is negative h, and the height here is h. So now I put my coordinates in for what they're going to be. So D right there is at negative b comma h, E is at b comma h, F is at b comma negative h, and G is at negative b negative h, like so. Alright, let's move it on up to number 4. Look on this front side still at 4, 8, and 11. So for number 4, we are currently here. This point is 0, 0, the origin. We have 0 up to P and out to A, which means this one's going out to A and up at the height of P. Okay, so use what you have here from your other coordinates to figure out your missing spaces there. Do the same thing over here for number 5 and 6, same idea. Let's look at number 8 real quick. We're out here, we're going out to negative k. So this distance right here is negative k, which means this distance is also negative k in terms of how far out it's going. So we can put a negative k right there. For this point, we know we came out to negative k, but how far down do we go? Let's look over here. This one went down to negative c, so we put a negative c right there. Over here, our x value goes out to, how far does the x go out to? The x goes out to k, because based upon there, it's the same distance, k, and it doesn't go anywhere on the y part, so it's just a 0 there. Good, number 11. 11 is a little bit different here. Okay, we have a point here, b, for my x value. So this is b, up to there is b, and then this part here is s plus b. So if this is b, then this becomes my value of s, right there. So we can say this is s, I don't need to write it there. So point there is s, and let's see, yeah, and in terms of how far up we went nowhere, so we're at 0. So s comma 0. Right, because that's the B point there. Let's take a look at the back side. Looking at a few on the back side here, just a few of these today. It says to find the missing coordinates and find the midpoint of each diagonal. Okay, so in terms of how far out we went out here to T, that's the value there, so we can put that there as well. Over here, we notice we went out to R, so we can put that one down here in R. In terms of how far up we are here, we're still at the origin, or at the y, we're y equals 0, so we can put a 0 there. And for this one, we went up to s here, so we can put that s right there. So those are my different coordinates for this shape there. In terms of the midpoint, to find the midpoint of, let's use this one first of all, the midpoint from here to here, what I'm going to do is I'm going to do the x values, okay, t plus r, this plus this, and we're going to divide it by 2 to see where it ends up being right there. That's for the x value. For the y value, same idea, I can do s plus 0, which is just s, and also divide it by 2. and that'll put me right in the middle right there. I can do the same thing for the other side. All right, my x value is t plus r, which is still t plus r, divided by 2, and then s plus 0, which is s, divided by 2 there. So they're actually the same, which shows you and proves that they are going to be meeting at the same point there. All right, number 14, a little bit of 14 and 14a. Take a look at this here. Okay, so if this is negative n comma 0, and this is n plus m, all right, we can say, well, what's that going to be? Hard to say. All right, so what we have here, if we draw a little line there, we can make this kind of match. So what the distance is from here to here is going to match the distance here to here, which means this has a length of m right there. So the coordinate for E is going to be m comma 0, right? Because of this triangle, this has a length of n right there, so this must be a length of m on that bigger part right there. So that's my coordinate for E, is at m comma 0. And for F, we are going over 0, but we're going up to this point, which we look across, is at P. Okay, so how do I show the opposite sides are parallel? I can use the slope formula to show that they're parallel, and that would be the y2 minus y1 over x2 minus x1. So I'm going to use the values there. So let's take a look at the lines FL, and we'll look at the line FL compared to AE to see if those are parallel lines. If they are, then our slopes should match. So let's look at our coordinates that we have there. So F, real quick, I'm going to jot it in, is at 0, comma, P. That's my value for F. So now I have all my coordinates listed there. So my y2 is going to be P minus my y1, which is P, divided by x2 minus x1. P minus P is 0 over n plus m. So nothing divided by whatever is equal to 0. Great, no slope. It's a straight line. Looking at this one here, we do our y2, 0, minus our y1, 0, over our x2 minus our x1. Again, we have 0 over m plus n, which is still equal to 0. So because those slopes are the same, it's a set of parallel lines. So we could put a little mark there. It's parallel. Let's take a look at the last one. Compare FA and LE. Okay, so for FA, we're going to look at the y2, which is P, minus the y1, which is 0, over x1, 0, minus the minus n. So we're there. So P minus 0 is P, and minus n is a positive n, so I have Pn. Let's look at the LE line. We have y2 is P minus 0, and we have n plus m minus m. So P minus 0 is P, and m cancel out, so I'm left with that. Pn and Pn are the same, so because they are the same, these are also a set of parallel lines, and I can mark them like so. Alright, so that's how you prove that the sides are parallel. In terms of showing that they're congruent, you're going to want to use your distance formula, which is the square root of, you recall, x2 minus x1 squared plus y2 minus y1, put the 2 down here, y1 squared. Okay, so you can plug those in and figure out what you get there, just to help you out. Hopefully I get you a little bit of your homework done. Good luck with the rest, and we'll see you next time.